So I will talk today about macros 2.0. So Rust has a macro system, and it consists of two parts: procedural macros and declarative macros. And macros 2.0 is a new system that spans both procedural and declarative macros, and it is sort of implemented in the compiler, but not completely. And there wasn't progress on this system for some time, so it still cannot be stabilized. And I will talk about its existing design and possible issues for stabilization. So what macros in Rust do in general? They take some input tokens, transform them in some way, and produce output tokens. Tokens are the most atomic element in Rust language. It is either identifier or literal or some punctuation or a group of those in brackets. So for example, here we see a sequence of tokens, and we see a macro invocation. Then macro expansion happens, and somehow this macro transforms this token sequence and changes the order of non-identifier tokens. Then tokens outputted by the macro are parsed, and they can be parsed as an expression or a type or an item or something else depending on its position in code. The first kind of macros is procedural macros. They take input, process input, and output tokens all using just library APIs. So absolutely arbitrary processing is possible. On this slide we can see a definition of a procedural macro, and we can see that it takes tokens, output tokens, parses the input tokens into some intermediate representation, then does something with it, and then produces some output that is based on it, all using library APIs. Declarative macros are basically a syntactic sugar for all of the above. The functionality is a bit limited, but still enough to cover some most common patterns that are useful in practice. Declarative macros are simpler to write than procedural macros, so they are more convenient to use. For example, in this declarative macro, we can see some syntactic sugar for parsing input. For example, here we parse tokens as an expression, and here we parse tokens as a sequence, comma delimited. And we also see some syntactic sugar for producing output and processing this input. For example, here is the syntax for transforming a sequence. In general, like any language feature rather than a library feature, it is harder to bring it into the language because syntactic budget for the language is limited, and it is usually cheaper to add standard library APIs than to add something into the proper language. So we need to decide which features are common enough and useful enough to have a dedicated syntax. And for procedural macros, third-party libraries can just cover any missing functionality that is not covered by a standard library. And for syntax in the proper language, is it harder to do that? Here are links for some tracking issues for macros 2.0, for procedural macros, and for declarative macros. And for procedural macros, the main blocking issue is the hygiene. And for declarative, it's hygiene plus syntactic sugar. So it's a strict subset, and we need to fix and stabilize procedural macros first, and then proceed to doing something with declarative macros, because it's strictly more work. Proceeding to issues with procedural macros 2.0. Here we see some situation with resolving names produced by macros. For example, here we see a macro definition. Here we see a function that is located at the point of macro definition. Here we see a function that is located in a different place. This is a place where we call this macro. And the macro contains call to a function named name. So which name will we call here? This one or this one? The answer depends on the macro hygiene. And if we resolve at the definition side, then it's called definition side resolution, and at call side resolution. The existing stable macros in Rust use call side resolution in general, at least for functions. And the new proposed system is supposed to use definition side resolution. With definition side resolution, macros are really similar to inline functions from name resolution point of view. And if we see some name inside the macro, then it will be resolved more or less like if it was a function. And such macros are called hygienic. And we have a library API, stable library API, for producing spans that have this hygiene property. And for call side name resolution, macros are very similar to, for example, C macros or macros expanded manually, where we're just copy-pasting code from a macro to its call side. And they are called non-hygienic. And there is a stable API in the library that can be used for this kind of name resolution. In rustc and in Rust in general, these name resolution properties, also called hygiene data, they are attached to spans together with code location properties like maybe line or column or file of the piece of code. And they are combined into a single structure called span. And this span is an internal structure in the compiler, and it is also a public stable API in the standard library, namely in the proc macro library, which is API for procedural macros. Each token produced by macro has its own span, so we can attach hygiene information in a very fine-grained way, and a single macro can produce both hygienic and non-hygienic tokens. And here is some curious example. The currently existing macro rules in Rust, they are partially hygienic, and local variables and some other things are resolved at definition side, but most of names are resolved at call side. So, for example, here we have a macro rules macro that produces function call, function, local variable as an argument. And a local variable is resolved at macro definition side, here. Usually, you cannot use names from outside of macro, but here the name is visible at definition side, so we can resolve it like this. And function is resolved at macro call side. So here we call the macro, here function definition at macro's call side, so we call it. And yes, the result prints 10. Because macro definitions can produce other macro definitions, some complex cases of nesting are possible, including macros with different kind of hygiene. For example, here we have a hygienic macro 2.0 that produces a non-hygienic macro, and the result doesn't currently compile, but it's a questionable case, and I'm not even sure whether it should compile, and it depends on the specific model used for hygiene. So we proceed to some specific models. In the past, Rust used the model described in the first link. The paper is called Macros That Work Together by Matthew Flat. And there is also another paper called Bindings as Sets of Scope by the same Matthew Flat, 2016. And both models were used and tested in the Racket language, which is a language from the Scheme family. And in 2016-2017, Rust adopted something that reminds sets of scopes, but this was implemented by Jeffrey Seyfried, but nobody really knows how close it is the set of scope system, and there is no some formal model of the current Rust hygiene system. To be stabilized, to span dev side, API be stabilized, we need to formalize this system and document this system. And the especially complex cases are nested macro definitions, especially with different hygiene, and the type relative name resolution, where it is harder to say what is definition and call side exactly. Span dev side currently has other missing pieces in the implementation. For example, old macro rules that are in theory should be visible at the definition point of macros 2.0 are not actually visible in the current implementation. And global names available to the whole crate are also not visible to macros 2.0 when in cross-crate scenarios, when that macro 2.0 is defined in a different crate. To fix this, we need to store some more information in metadata for compiled crates. And there are some other technical issues like hygiene data for non-expanded code, not produced by macros in different crate, being considered identical, while it is not actually identical. It is produced by different crates, and we need to fix it to address the previous issue, because global names available in different crates are different. Here we have an example of the problem with global names. Here we have a macro 2.0 that is supposed to resolve at definition side. And at definition side, we have this option passed external dependency crate that is supposed to make the name dependency crate globally available to this crate. So we should resolve it here. And if we call this macro in a different crate, this is probably not visible, then there may be problems. There may be a different extern dependency crate used here, or no external dependency crate at all. And in that case, this will either not resolve or resolve to the wrong crate. But it needs to resolve to this dependency crate if this macro behaves like an inline function, what we want. And the example with macro rules, here we have a macro 2.0. This is definition side. This is macro rules, which should be visible at definition side. These macros are scoped like let variables, so it is visible only here. But currently, if we call this new macro, it will not find all macro, because the compiler not currently records these let-like macros at the definition sites of macros 2.0. And declarative macros have their own set of issues, mostly related to syntax, to syntactic sugar. For example, in the top-level syntax, we may want to control the bracket kind accepted by the macro, maybe not. And some syntax for hygiene opt-out, so the span call site API should be available for declarative macros, not just procedural macros. And maybe macro input matching algorithm should be better to provide better compatibility with future language changes. There are some other small breaking changes that we can make to the macro syntax. And of course, it is possible to change the macro syntax entirely, but I haven't seen any radical proposals so far. But of course, it is still possible. Here we can see an example for controlling the bracket kind. Macros in general, they can be called with all kinds of delimiters, brackets. And there is also an attribute form that also can be called with all kinds of delimiters, including no delimiters at all. But for some macros, like for example vector, we may want to restrict this set and only make it callable with square brackets, for example. This is not currently supported. And for procedural macros, it is very easy to fix. We just need to add in one new API. But for declarative macros, problems like this, they may be not very difficult technically, but they still set roadblocks for stabilization of features, because we need to decide whether to support it or not support it, how exactly, what syntax to use, whether to put this restriction on the whole macro or on individual macro matchers, and to make several decisions to proceed to actually stabilizing or something like this. Here's another issue with hygiene opt-out or using span call site API in declarative macros. In this example, we see a macro 2.0 that produces two items. One has a definition site hygiene, and one is using this opt-out, using the hash syntax. Fully hygienic names produced by macros, not used by produced, cannot be used outside of macros. So even if we produce this function foo, we cannot use it. So maybe it's not visible. Foo is error. Foo is not visible outside of the macro. But bar is visible because it uses the hygienic opt-out. Of course, it's not very useful to produce names that you cannot use. So the workaround for Macros 2.0 is right now passing these output names as input and regenerating them. But this kind of opt-out may work better. Yeah, so what is pros and cons? This syntax just mirrors available procedural macro API on span call side. And the drawback and the argument against this, some people said, is that here, the opt-out, you need to search it somewhere in the macro body. It is not visible in the macro interface that it produces a name called bar. And there was an argument that this kind of opt-outs, they need to show up in macro interface again, not just in macro body. It is also possible that we need to add syntactic sugar not for this feature, but for some more general feature. For example, inheriting hygiene data, not just from call site, but for arbitrary tokens as well. There is a prototype implementation for this, but it was not merged due to these concerns. And another issue with declarative macros are macro input matching. Here is just example of a macro matcher. There is several alternative. We are matching macro input against all of them. And this one matches ABCD, this one matches any expression, and this one matches a sequence of identifiers. In this example, we match this one, and so the output is free. And notice that ambiguities are possible. For example, if we passed ABCD, it would match both this arm and this arm too. And just A would match this arm because A is an expression. And this arm too because A is also an identifier. And due to these ambiguities, we have some problems with language evolution. Syntax in Rust is extended sometimes, and if we add some new construction to the language, then we can get new ambiguities too in macro matchers. For example, if here, yes, ABCDE suddenly became an expression, then we would have an ambiguity between this and this, and we would start to output 2 instead of 3, and that would be a breaking change. So macros inputs that previously matched just one alternative now can possibly match more than one alternative after some syntax extensions in the language. What we should do if we see ambiguities like this? We could produce an error that would be impractical, and we could disambiguate somehow. The current approach is to disambiguate in favor of the first match. There are some minor bugs in the implementation, and the relevant issue is linked. But in general, it works. But another possible alternative to use in Macros 2.0 is match not the first matching arm, but more specialized matching arm. For example, no, we don't have a good example here, but we have a good example on the next page. For example, if we have a matching a macro like this. In the first match, we match any expression, and in the second, we match a const expression. So, in theory, if we pass this one, we should maybe match this and this. And right now, the rules are we're matching the first one, so we should print one, but we actually print two. For backward compatibility, there is specific hack in the compiler that makes expr matcher to not match const expression, just for backward compatibility. And easily, we would address this by considering the const matcher more specialized than the expr matcher. And the expr would still match the const expression in that case. Const is more specialized because any const braces expr is expr, but not otherwise. Currently, this future compatibility is addressed by some following token restrictions. For example, expressions can contain plus signs. So we prohibit expression matchers from being followed by plus signs. And when we write a matcher like this, it won't compile. So we won't have ambiguities when passing, for example, 1 plus 2. But it doesn't prevent all regressions because in case of const, the const expression is not a token that follows expr. It kind of wraps it from both sides. And besides input matchers, there are also some small breaking changes possible. For example, the sequence transformers. Technically, the current syntax looks like the example above, but technically the star is not necessary. You can already produce the output without that star. And in general, the macro syntax, it is very noisy. So anything that can remove noise is potentially a useful change. So it is possible that we can remove these stars from sequence transformers, but it is also a breaking change. So it needs to be done before stabilization of macros 2.0. Some current organizational status. Nobody is working on this feature, unfortunately. The last major change in this area was a couple of years ago when Aaron Hill implemented encoding of hygiene data into create metadata. Before that, hygienic macros didn't work in cross-create scenarios at all. And there is some hope. Recently, a macro working group was started, and the group has started, yes, but it is not yet clear to me that we will do actual implementation work and not just design. So any contributions are welcome, especially from people who are familiar with Racket or Scheme and can read the sets of scope pages and understand it, and maybe tweak it and apply it to Rust realities. That's all. Thank you very much.